This PowerPoint presentation will highlight some of the important concepts found in Chapter 1 of the Introduction to Atmospheric Science, being taught as Weather 101 at Mohawk Valley Community College. It will discuss many but not all of the PowerPoint slides in this AMS presentation. This chapter basically deals with some of the basic characteristics of the atmosphere and weather, and specifically covers differences between weather and climate, timekeeping, the overview of weather systems and weather maps, and an introduction to satellite imagery and radar. One of the first concepts we need to define is basically what's the difference between weather and climate. And as described here, weather is a state of the atmosphere at some place in time and has a variety of quantitative variables such as temperature, cloudiness, precipitation, wind direction, etc. Climate is weather conditions at some locality averaged over a specific time period, which generally is approximately 30 years and is updated every 10 years or so. This idea of timekeeping is important for weather in a variety of ways, as we'll see. You can visualize by way of the map that there are a number of zones or time zones which we will utilize over the course this semester. The weather observations around the world, including things like surface area, our surface radar, and other observations, are always taken with respect to what is known as standard time. By convention, the world's weather communities use a 24-hour clock, similar to the military time you may be familiar with, based on the zero longitude meridian, also known as the Greenwich meridian. Before 1972, this time was called Greenwich Mean Time, but now is referred to as Coordinated Universal Time, or Universal Time Coordinated, UTC. Its coordinated time scale is maintained by the Bureau of International Measures and is known as Z time, or what we call Zulu time. To obtain the local time, you must subtract a certain number of hours from UTC depending on how many time zones you are away from Greenwich, which is located in England. One of the more important things that we need to understand is weather systems and weather maps. To understand weather systems, we also have to appreciate the fact that there are things called highs and lows, which are referring basically to air pressures in specific areas of the country or in specific environments. High pressure area is relatively high compared to the surrounding air, versus low, which is generally lower when compared to surrounding air. Highs and lows give us different types of weather. Highs are generally associated with fair weather, generally track from the east and southeast, and a very important thing is that they rotate clockwise and of the sinking air that's found in that particular hemisphere. The lows generally are associated with stormy weather, have a counterclockwise rotation, and generally track toward the east and northeast from the west. This next slide gives us a map which describes the highs and lows and various symbols associated with a typical map that you might see. As explained previously, high pressure systems are called anticyclones, and low pressure systems are called cyclones. On the bottom of this particular map shows you some of the symbols associated with the maps that you will be observing over the course of the semester. These symbols will help us define the fronts and where the highs and lows are associated with that. Over on the right hand side of that situation are the symbols relating to precipitation, whether it be rain showers, thunderstorms, snow, fog, etc. You should become familiar with these as we begin to look at maps a little more critically. To understand weather systems, we have to appreciate things called air masses, which are really nothing more than very large volumes of air covering hundreds, if not thousands, of square miles. These air masses are typically uniform in their temperature and humidity, and they generally get their characteristics from where they originated. For instance, if they're a cold, dry air mass from higher latitudes, or warm, dry air masses from subtropical regions, these air masses will have a tremendous effect on our weather and the weather systems we're going to be looking at. You certainly appreciate that polar air masses are going to be colder in winter and milder in summer, and tropical air masses tend to be fairly stable and have less seasonal variation due to the sunlight that is found in the tropics and the duration and intensity of that sunlight. Air masses obviously are going to modify as they move from their source to their other region that they are moving to, and they will take on more of the characteristics of the region that they're passing over. So there are changes in air masses as they occur over time. When we talk about fronts, these are simply areas where generally warm meets cold or cold meets warm in terms of air masses. As we can see from these diagrams, when we talk about a warm front, generally warm air will override a cold front or cold air, and cold fronts generally dive down and go below warm air. And that's typical in terms of most of the fronts that we will look at. It's at these fronts that we have some very, very interesting weather from time to time, as we will see as the warm meets the cold or the cold meets the warm. Fronts are very, very complex weather components, and the next 3 slides or so will give you some indication as to some of the characteristics of fronts, such as being as three-dimensional and precipitation builders, etc., etc. So take a look at these next few slides and look those over, because they've got some detail about fronts, and that will be important to us down the road. This next slide gives us an idea about how and what describes the state of the atmosphere. And obviously things like temperature, minimum and maximum, dew point, relative humidity, and precipitation have an effect on the state of the atmosphere as we know it. These particular terms are important for us to know, so you should look over and appreciate what each one of these actually means. Minimum, maximum, dew point, relative humidity, and precipitation. In addition to the components of the previous slide, other things that describe the state of the atmosphere are things like air pressure, wind direction, and wind speed, as well as sky cover. These will all have an effect on weather and be very important for us to appreciate how as we go through this. This next slide begins a discussion of weather satellite imagery, and there are a number of different types of satellites, so let's take a moment and just talk about some that may be important to us as far as weather is concerned. Geostationary satellites are generally high orbit satellites above 22,300 miles, and they orbit at the same speed or rate as the Earth's rotation, and they orbit in the same direction. Currently there are 2 that provide a view of North America and adjacent oceans up to latitudes of approximately 60 degrees, and they are positioned over the equator at 75 west and 135 west longitude. These are stationary. They stay over one particular spot throughout their life. A second type of weather satellite which is important for us is something known as the polar orbiting satellites. Compared with the geostationary, these are relatively low orbit satellites, somewhere between 500 and 600 miles above the Earth. They provide overlapping north-south strips of images, and they pass over the same point twice every 24 hours. So they are not geostationary, they are polar orbiting, going around the poles, as you can see from the slide on this particular map. Now, the importance of satellites obviously is to produce images which will give us some indication as to the weather across specific regions of the world. Visible satellite image gives us black and white photography of various parts of the planet. The problem with that imagery is that it's only available during daylight hours, but it does give us some very, very good information. We know that highly reflective surfaces appear bright white and less reflective surfaces are much darker. Therefore, we can see over in this area some reflected surfaces appearing white, which are probably clouds that are associated with this. Whereas over in this western part of the United States at this particular time on 19th of October in 2011, there were very few clouds associated with that particular image. Another type of image that we can receive from various satellites are things called infrared satellite images using a different wavelength of light, and they are better than the visible basically because they are available anytime, not just during daylight. And they also provide temperature comparisons of features within that particular image, indicating temperature distinctions, such as higher cloud tops appear whiter, which we can see down in this area, versus these clouds over here, which are not as white. And we know that they are higher clouds because they are colder, and that is exemplified by the infrared satellite image that we see here. Yet another satellite imagery is water vapor satellite images, which enables the satellite to send images of plumes of moisture found within the atmosphere. The whiter the imagery, the more moisture we generally find in that particular region. Upper level clouds generally are very, very bright white because of the amount of moisture associated with them. Weather radar is a very important tool we use in meteorology, and we will learn much more about that in later chapters, but just as an introduction, it's very important to have radar as a complement to satellite surveillance. Probably one of the most frequently used types of radar are Doppler radar, which detects the movement of various systems, and it's a very, very good tool for detecting tornadoes and other wild weather, which you probably have seen on the Weather Channel or some other TV show. One of the interesting things we are able to do is take a combination of satellite and radar and combine them into composites of weather maps. Here we see a composite of infrared satellite image and radar echoes, which give us some very interesting looks at and ability to interpret the weather more efficiently and effectively. This PowerPoint ends basically with the idea of looking up into the sky and seeing things called clouds. Clouds are nothing more than water droplets or ice crystals or combinations thereof. And we know generally that relatively low clouds are composed of primarily water droplets, and they generally have relatively sharply defined edges, whereas those higher clouds, such as the cirrus clouds that we see here, are composed of tiny ice crystals and generally look fibrous or wispy because of the nature of the way that water is aggregated in those particular environments. Fog, which is really nothing more than a cloud in contact with the ground, is often seen in specific areas and are generally given warning that this is a particular fog area, and we'll figure out why as we get into the course. When we talk about clouds, they are fairly complex in terms of their descriptions, but if we keep it simple, we can talk about simple cloud formations, and one of those is a stratiform cloud, and this is a sheet-like cloud formed in horizontal layers, and versus the cumuliform cloud. Oh, sorry, let me go back. Cumuliform clouds, which are the puffy like cotton balls that you can look up at the sky and see fairly often. The next several slides talk about some different types of cloud types. Clouds of vertical development, cumulonimbus clouds, which we will spend some time with later in the course, and clouds that move in different altitudes at different directions, indicate wind shifts. So we can use clouds to determine some very distinct things about the weather and the atmosphere as we are looking at it specifically. Thank you for listening. I hope this helps you out with Chapter 1.